For our next example, we're going to take a look at a program that simulates the casino dice game called Craps. And in that game, the player rolls 2 dice that each have the values from 1 through 6 on the faces of the dice, and the sum of the dice is calculated. If initially the sum of the dice is 7 or 11 on that very first throw, the player wins. If the sum is 2, 3, or 12 on that first throw, that's called craps, and the player loses in that case. And for all the other values, 4, 5, 6, 8, 9, or 10 on the first throw, that becomes what's known as the player's point, and the player must then roll the point before rolling a 7 in order to win the game. So if the player rolls anything other than the point value or a 7, the game just continues until the player wins by rolling the point or loses by rolling a 7. Now, the program that we're about to look at focuses on the structured programming capabilities of C#. So it's not a fully object-oriented program. And basically what we're going to do is define a class called Craps that consists primarily of static member functions, and take a look at the various capabilities of structured programming in C#. We're also going to introduce a couple of new capabilities here, and in particular the concept of an enumeration, which is used to define sets of named constants that you can use in your code and make your code a little bit more readable. Now, because we're going to be using the random number generator many times in this program, we've declared a field in the class, a static variable called random numbers, that's private to the class. Its type is random, and we are once again initializing it with a new random object. When you declare a field in the class, whether it's a static field or an instance variable field, either way you have the option at the moment you declare the field to also initialize the field. So we're creating a new random object here and immediately assigning it to random numbers. And in reality, what's going to happen is at the time that we execute this program, because this is a static field of the class will get loaded into memory, the static fields of the class will get created in memory, and they will be initialized as the program's main method kicks off and running. All of the code that does that is hidden from you, but it's all being generated by the compiler. So we declared it as a static field of the class, static so that it can be used from the other static functions in the class like main, and as a field so that we don't have to recreate it every time we need a random number in the program. We want to reuse the same random object repeatedly, and that's actually important for proper randomization. If you create multiple random objects in a program, your program often will become less random than if you just reuse one random object over and over again. So that's why we made it a field of the class, and again it's static so we can use it from the class's static functions, now, or methods rather. Now at line 11 we have our first enum in C#. Now this concept came from C and is used in many C-based programming languages. And enum helps you define a new type. The type name is specified after the enum keyword, and then you specify a set of constants inside the curly braces of the enum type. If you don't give values to those constants, they're automatically going to have the values starting with 0 and incrementing by 1 for each subsequent constant. So at the moment, continue is 0, 1 is the value 1, and lost is the value 2. But you can put an equal sign after any constant to give it an explicit value. The names of the constants within a given enum must be unique, but you could actually have multiple constants with the same value if you wanted to. Now we declared the enum private because we're using it only inside the class called Craps. It's used just to make our code a little bit more readable. So if we needed this enum outside the class called Craps, then we could make it a public enum, and users of class Craps would also then have access to the public enum called statics. Now, in addition to the 3 different game status values, continue, won, and lost, we have several other constants that are defined by the dice names enumeration. And these are common names for certain values of the sum of the dice that are used in casinos, for example. So when you roll 1 and 1 for a sum of 2, the casinos typically call that snake eyes. And sometimes they refer to the sum of 3 as tray. The sum of 7 is sometimes called 7 or craps. It depends on the casino. Yo 11 is what you hear some people yell out when the sum is 11, and sometimes they say boxcars for 12. So to add a little flavor here, we use the names that we hear in casinos for these various values. Now, these are going to be used to help us determine specific values that help specify whether the game is won or lost at a given time. Remember, if you roll a 7 or an 11 on the first roll, you win. And if you roll a 2, 3, or 12 on the first roll, you lose. And we need to test for those values in our code. Now, within the main method, we have most of the logic of the program. Initially, we create a variable of our enum status type called game status, and we set it to the value status.continue. So the way you access a constant from an enum is the enum type name followed by a dot and then the name of the constant that you've defined. And if I hover over that, you can see that the type of that constant is status. So again, each of the values within an enum has the type of the enum itself. And the underlying actual data type of those values is int. However, you cannot implicitly convert an enum constant to an int. You have to use a cast operator in order to do that. So here at line 28, we also declare an integer variable myPoint and set it to 0 initially. This variable will store the user's point if they don't win or lose on the first roll. And then we perform our first roll of the dice by calling our own roll dice method, which is defined a little bit lower down in the code. Now, main is static, so if I'm calling this function, this method directly, it must also be a static method. So if I scroll down here, you can see that roll dice is indeed declared to be static. So again, going back up here, notice the syntax of the method call. If you ever see a method name by itself, the first thing you should think is this is another method defined in my class. And as we get into the relationships between classes and the concept of class hierarchies and inheritance, then we'll enhance that rule to include other classes in the class hierarchy or the .NET Framework class library as well. But for now, anytime you see a method that's just the name of the method followed by parentheses and possibly some argument values as the way that you call the method, that means that the method is part of the current class. So we're going to roll the dice, and this method is going to return to us the sum of the dice. It's also going to display what that sum of the dice was. And then based on that value, we have a switch statement that helps us determine if the game was won or lost on that first roll. Now you'll notice that my switch's controlling expression is the variable sum of dice, which is an int. However, the cases that I'm testing are constants within the dice names enumeration. And again, there is no implicit conversion between an int and enum constants or between enum constants and an int. So in order to compare the sum of the dice to one of these enum constants, I have to first cast it to the appropriate data type, dice names in this case, and then I can test against the cases that you see listed here. So on the first roll, if the user rolls a 7 or an 11, then they've won the game, at which point we set game status to status.1. Remember that it was set to continue initially. If they roll a 2, a 3, or a 12 on the first roll, that means they lose, so we'll set game status to lost, status.lost. And by the way, remember that these break statements are absolutely required in C# at the end of the statements for a given case or set of cases. Finally, we have the default, which is if the first roll did not cause the user to win or lose, in which case game status is continue, My point is set to the sum of the dice, so we keep track of what the winning value needs to be, and we would then display the point value at that point in the program. Now, after the first roll, we're going to continue rolling until the game status is no longer equal to continue. So while the game status is equal to status.continue, we need to keep rolling and see if we either roll the point or roll a 7. If we roll the point, we win. If we roll a 7, we lose. For all other values, we just roll again. So as long as we're still equal to continue, we roll the dice once again and assign the value to sum of dice. We then check to see if the sum of the dice is equal to my point. If it is, we've now won. Otherwise, if the sum of the dice is equal to dice names.7, and again, notice the cast operator, so we can compare an int to an enum constant value. If the values are equal, then we set game status to lost in that case. For any other value that's not the point or a 7, we simply return back to the top of the loop and roll the dice again. When that loop finally terminates, then the user has won or lost the game. At that point, we check to see if game status is equal to status.1, and if so, we display player wins. Otherwise, we display player loses. So main is controlling the lifetime of one game of craps in this app. Now, the roll dice method that's called from main in a couple of different locations is going to produce a couple of random numbers in the range 1 up to but not including 7, so 1 through 6. And each time I call next, I'm going to get a different random number. It could be the same value, but it's just the next random number in sequence for that range of values. So I'm going to assign those to die 1 and die 2 respectively, then calculate the sum. I'll then display what the player rolled, both values of the dice and the sum of the dice, and I will return the sum back to the caller so that we can use it to help figure out the won, lost, or continue status of the program. So let's go ahead and see this program in action, and I'll run it a few times so we can see different results. So in this case, the first roll was a 4, which is not 2, 3, or 12, and it's not 7 or 11, so we didn't lose and we didn't win. We just have 4 as our point, so we see that on the next line. And then we start rolling, and we have to roll a 4 before we roll a 7 to win. So you see we rolled 8 twice in a row, then we rolled a 7, so the player lost in that case. If I run the program again, in this case, the first roll was a 5, which is the point. Then we immediately rolled a 5 again, so the player won in that case. If I run the game again, let's see if we can get, there's a win on the first roll. Player wins because they rolled a 7. Let's see if we can get a roll or a loss on the first roll. That's another win. I'm going to do Control F5 so I can run this a little bit faster. And we'll run it a few times here, see if we can get a loss on the first roll. Not having much success on that. Here we got another win on the first roll. Another point, another point. And as you can see, not always do you get win or loss on the first roll, and I'll actually stop at this point and let you take it on your own and keep running it so that you can see a loss on the first roll as well. So a couple of things to just point out in this example. Again, the enum concept is new. It is something that was inherited into C# from the C programming language. One thing about enums in C# is that they become their own data types. So again, if you want to compare their values with integer values, you can, but you need cast operators in order to do that. You can actually specify the type of the underlying constants if you want as well by following the type name with the type that you want to specify as the underlying type of the constants. So this can be any of the integral types if you want. So for example, if I wanted to store it in less memory, I could represent the constants as bytes instead of int values. So that's an enhancement on enums over some of the other programming languages. So that was new. And then separately, the other thing I wanted to show you is a concept called code snippets. You'll notice here that in our switch statement, we put all of the different cases that you would use for the dice names enumeration into the switch that we're testing. Turns out that when you start typing any control statement in C#, there's a concept called a code snippet that can help you write your code a little bit faster. So if I type switch and then hit the tab key twice, it will start to fill in the switch statement. And now, let's say I wanted to create a switch statement that was based on the game status variable of type status. If I type game status here and hit enter, it goes ahead and puts all the cases of the status enumeration in there for me, and then I can go and edit the code as appropriate for what I need to do. So that's a concept called a code snippet, and it can help you write your code a little bit faster. And just to demonstrate, I can do this, for example, with an if statement. If I type if and then tab, it'll fill in the shell of an if statement for me, and then I can edit the code accordingly. So that's a nice little feature of the IDE that's geared to helping you be more productive as a programmer. So in this example, we focus primarily on structured programming concepts. We introduce the concept of an enum, and as we go forward now, we'll start to get into some more of the object-oriented programming concepts as well.